Hello everyone, welcome to Minshe Academy. I am your geography teacher Shoham. So, we are already done with 3 chapters of geography. The Earth as a planet, number 2, the geographical gates, latitudes and longitudes, and number 3, what is the chapter number 3? The chapter number 3 was the Earth movements, that is rotation and revolution. These are the 3 chapters of your class 9 I.C.S.E. curriculum. We are done with these 3 chapters. Now, it's time to move on to the next chapter, the 4th chapter of your I.C.S.E. curriculum in geography. So the chapter is the structure of the earth. So geography, we know it's basically description of the earth. So that is there. So structure of the earth is very logical that it would be part of geography. But what are the benefits that we will be getting from learning this chapter? What are the things that we are going to learn after going through the entire course, right? Entire chapter, what are the things that we're going to learn? That means why we need to know about the Earth's structure or Earth's interior per se. First is to know about Earth's formation and evolution. You all know Earth was formed around 4.6 billion years ago. Since then, it has been noticed that the Earth's surface is not uniform. It has evolved over time. Sometimes there was only one big continent, that was Pangaea. And now we know there are multiple continents from America, North America, South America, Eurasia, that means Europe and Asia, and Africa, Australia. These are various continents that exist. So how has it evolved? What is the reason for their evolution? Why a single continent, that is Pangaea, broke into this many continents, right? This is the first thing that you're going to learn. That is, you are going to learn how has Earth formed and evolved over the years. Number 2 is predicting and understanding natural hazards such as various geophysical phenomena. What do you mean by this? For example, you know the earthquakes, you know volcanoes, right? These are the names of things that you have already heard. Either you have heard it in the news or even it can be part of your lower classes curriculum. You have already heard it, that's for sure, right? So this chapter will also give you insights or give you ideas about the formation or occurrence of those events. And once you know why these things happen, you will also know how to mitigate them. Or number 2, if not mitigate, how to minimize its effect, right? So this chapter will also tell you what about how to understand, it will give an understanding and how to minimize its effect so that it doesn't affect human being to an extent that it can, right? Number 3 is to understand Earth's magnetic field. What does this mean? You will, after you know the Earth's interior, how it is being divided, you will come to know, okay, why does the Earth have its magnetic field? That is something that you're going to learn. And how does it change? Why it changes? Everything. A clear understanding of the Earth's magnetic field. This is something that you're going to learn after going through this chapter or after completing this course or video, whatever you say. Number 4 is to understand mineral exploration. This chapter, after you study, you will understand the various minerals that are there in various layers of the Earth. We will be dividing the Earth into various layers and what are its compositions, and that will help us understand, okay, here these minerals can be found, there these minerals can be found, and on the basis of that we can initiate mining projects because it is very beneficial. We all know mines are being mined, right? And we extract resources from there, so it would be beneficial in that way also. And last but not the least, to understand the evolution and present composition of the atmosphere. How atmosphere formed, right? And what is its present structure can be understood. You will, maybe this is not something, this is higher level, but you will at least come to know, you will understand how is atmosphere formed. It has link with the interior of the Earth, right? The interior of the Earth has reasons or has its cues about what is the existing quality or composition of the Earth's atmosphere. So the atmosphere of the Earth has link to what? The interior of the Earth. So this is why these 5 reasons give you a concrete idea why you need to learn this chapter and what are the things that you're going to learn or get out of this chapter, right? Now let's move on. Now, first only I told you that Earth was not the same. So Earth was formed around 5,000 million years ago, right? It is, I said you 4.6 billion years. So it is kind of roughly, it's an approximation. Whenever in this chapter, whenever you will be learning about the thickness, the depth, whatever numbers are there, always remember this one thing. It is not exact. It is an approximation or it's a generalization because it is not possible to actually gauge it, right? The exact, or science hasn't reached that level where it can exactly determine the numbers. So these are approximations. So Earth was formed. So Earth was formed 5,000 years ago. And I have told what? It is undergoing change. Are there examples that it is undergoing change? Yes. The Atlantic Ocean widens by 10 centimeters each year. You can understand the Atlantic Ocean, you know, that is between American continent and between the Europe and Africa. The ocean that's there, it widens by 10 centimeters. So it has to have reasons. I told you that there was only one continent, that was Pangea, and it broke into multiple continents. And now the ocean floor is also widening. So there must be something, or there must be some mechanism, or else it wouldn't have happened, right? So there must be some mechanism responsible for it. Even because the Atlantic Ocean is widening, it is also noticed that the Pacific Ocean is shrinking day by day. You can understand that, right? Even there are examples of the Red Sea is in its infancy, right? We all know the Red Sea is in its infancy. So these are the changes that the Earth's surface is going through. And after learning this chapter, you will understand why it goes through these changes. What are the driving factors that affects or drives or instigates the change that is happening on the surface of the Earth? What we see, there are multiple layers of functioning that is occurring beneath it, right? We are seeing now, or we are observing, and remember, I am telling, you can understand Atlantic Ocean is widening by 10 centimeters. It is very minor. So in your lifetime, it will be not that impactful. But over the lifetime of humankind, it will be impactful. So this is the reason why we, after knowing about this, or this is why it is very important to know about the Earth's interior, because it will help us know about all the things that I've already explained or have discussed with you all, right? Now, first we will start with there are different realms of the Earth. So what are those different realms? And after learning about the realms, we will be continuing. So starting the chapter with realms of the Earth. There are 4 realms of the Earth, okay? Now, first is the lithosphere. What is the lithosphere? Any surface that you are seeing, the surface, the land, where is the soil, the forest, this is part of the lithosphere, right? We will be learning more about this, but for the time being, just understand what is lithosphere. Lithosphere is outer covering, the surface of the Earth, which provides the site for soil formation, the site for various kind of activities, even you are settling on the surface, right? So this is the lithosphere, where soil, plants, everything is growing, minerals are there, right? Now the second is hydrosphere. Any ocean, sea, all water thing on the surface of the Earth, that part or that realm is known as hydrosphere. We knew lithosphere is the surface, and water body, whatever, is coming under what? Hydrosphere. It's the liquid section. Now the atmosphere. Atmosphere, we all know this is the gaseous section, the thin cloud section or the thin layer which is surrounding the surface of the Earth. So that's the atmosphere. And the fourth, these are the 3 realms which are actually tangible or which can be seen. But the 4th realm you can't identify. It is basically something that is formed by composition or interaction of all the 3. So that is nothing but biosphere. So what is biosphere? Biosphere, you can see this, it is the composite zone that is inhabited by living creatures. And this zone where living creatures exist is known as biosphere. So this is the 4th limb of the Earth which is formed by interaction of what? the atmosphere, the lithosphere, and the hydrosphere. And the intersection where it is happening is in the biosphere. Clear? So these are the four realms. Now in this chapter, as we are talking about the structure of the earth, among the various realms, what is the most important, you think? Obviously, the lithosphere, right? Because it is the surface of the earth. It is the tangible portion that we are seeing. We are not talking about the atmosphere because it is not forming part of the earth's structure. And even the hydrosphere is not also forming the part of the earth's structure because it is the water bodies. That is not structure of the earth, right? Not part. So it's very obvious that we are going to study anything related to the realms of the earth. The realms that is important with respect to this chapter is the lithosphere. This is nothing but the solid inorganic section of the earth. As I already said, solid inorganic. Why? We know the surface of the earth is solid. Why inorganic? Because it is composed of various minerals, as I was already saying, right? So this is why it's the solid inorganic outer section of the surface of the earth, or the surface of the earth. So here you can see the mountains, the volcanoes, and even the ocean. Ocean is there, right? Beneath the ocean, there is also land. That is also part of the lithosphere. It is not part of hydrosphere. Clear? It is the part of lithosphere, which is known as oceanic crust, which you will be learning what is it, what not it is. But basically, to get an idea, it's part of the lithosphere also. So this lithosphere is about 17 kilometers in width. Remember, average is 17 kilometers. Here we will be saying variations about highest in the Himalayas. We see about 70 kilometers, right? The crust is at a length of about 70 kilometers. So this is an average that is given. Don't confuse it. Okay? So I think it's clear. Now, this is the mineral skin, obviously, as I already told you, because it is composed of various minerals. It is the layer where soil is formed, which is giving plants, right? The plants are formed on the soil. Without soil, plants wouldn't have been formed. Without that, carbon dioxide wouldn't have been there. Carbon dioxide wouldn't have been extracted from the atmosphere. That means through the process of photosynthesis, the Earth's surface is made livable because it produces oxygen and takes in carbon dioxide, which makes the planet Earth livable. So this is a very important part of the Earth's realm, or the Earth, right? So lithosphere, you can see it, right? So the lithosphere, or the outer surface, is mainly made up of two kinds of rocks. Number one is granite, and number two is basalt or basalt, whatever you say. Basalt is the correct pronunciation, I think, not basalt. Sorry for the wrong pronunciation. It's basalt. So the outer surface is made up of two types of rocks, majorly, it's granite and basalt. And the oceanic crust, continental crust, all these things you will be learning, where granite is more predominant, where it is less predominant. Everything you're going to learn. So take patience, have patience, and continue with the class. You will be learning everything. Now, we are going to study. By now you have understood, we are going to study about what? The interior of the earth, the various structures the earth is formed of, right? So how come we can know about the interior of the earth? There might be something that is giving us ideas about, or that is giving us information about the interior of the earth. So the sources of interior of the earth. The direct sources, the indirect sources. First we will be dealing with the direct sources, right? Direct sources means which directly we are getting ideas or information about the interior of the earth. And indirect sources means directly we are not getting, but we are getting a cue, or we are getting an idea indirectly, right? So here, direct evidence, mining. We all know mining happens. Mines are there where mining happens. In South Africa, there is the biggest mine, the gold mines in South Africa, which is about, I think, 80 kilometers in depth. Not 80 kilometers, 5 to 6 kilometers we dig, 3 to 4, 5 kilometers we dig, right? So from after going through the mines or drilling down, we come to know about the various compositions of the earth, right? So that gives us direct source about the interior of the earth. Drilling projects. What does drilling projects mean? Drilling projects are basically nothing but some projects which are done just to know about the interior of the earth. Such project was conducted in 1970 in Russia. At that time it was USSR, right? It wasn't Russia, the Russia that exists today. It was USSR. There, the project was thought of as an idea, right? That it will give us information about what? It will give us information about the interior of the earth. The idea was to know about the earth's interior. So this project was initiated. It wasn't like mining in terms of mining. We are drilling or we are excavating. Why? To extract minerals. But here it was the main objective or the sole objective was to know about the earth's interior. Here, this also up till a certain depth we can go, beyond which we can't, right? Volcanic eruption. Obviously, volcanoes, we all know, and during the time of volcanoes, lavas come out, right? So those molten magma which forms lava when it solidifies, these gives us understanding. After studying those things, we get an understanding of the composition of the earth's surface, and from what depth science has evolved to such an extent that it can also understand from what depth it is coming. So these are the direct sources which gives us an understanding of, okay, this is how Earth's interior. But it is very limited. Why? The interior of the Earth, as you can see from the image, it is very hot. Inside it's very hot. So, and even the Earth's interior, if you compare the radius of the Earth, it's 6350 kilometers approx, right? So the radius, if it is that deep, it is very difficult to reach to that extent. Number one, because of the huge temperature. Number two, because of what? Because of the depth, immense depth, which is very, till now it's not possible to reach to that extent. So direct sources help, but it is limited to a certain limit, beyond which mainly our idea of the Earth's interior has come mainly from the indirect sources. What are the indirect sources? Temperature, pressure, and density. So basically what happens, we know physics, right? In physics, there are mechanisms to measure the temperature, pressure, and density variations along depth. So if I know with 10 kilometers, if I am seeing, for example, I have gone up to 80 kilometers. It is possible that I have gone up to 80 kilometers. And I have lavas and stuff which are giving us cues about what? The temperature inside. So through that, I have identified a gradient. For example, what is a gradient? The amount of distance with which the rate is changing. For example, this amount after covering this amount of X amount of kilometers, the temperature is increasing or decreasing, whatever. So that has been developed, right? So these are indirect sources. Directly we are not getting, but indirectly through our scientific innovation and scientific advancement, these are the things that we have come to know. Number two, gravitational anomalies. We all know the gravitational force that works depends on what? The masses and the radius between them. We have already studied it previously. I have only explained it in the previous chapters, right? So it depends on the mass distribution. So obviously it has been noticed that the gravitational force that works is not working the same everywhere. When measured from satellites, there are scientific ways of measuring gravity from satellite. It has been observed that there is a difference. So this indicates what? This indicates there is a difference in the distribution of minerals along the surface of the earth or in the earth's interior. Magnetic surveys, right? I have already told you that after after going through this chapter, you will be coming to know about why earth has its magnetic field, right? So magnetic surveys has been conducted which have given idea about, okay, there must be magnetic elements somewhere, right? So these are what? These are indirect because we haven't gone there to extract the samples. We have, through our own cognitive knowledge, we have gathered those information. Number four, meteorites. We all know meteors. Meteors, when enter the surface of the earth, on the earth's atmosphere, it becomes meteoroids. And when it reaches the earth's surface, it becomes meteorite. It is a part of a celestial body which is very small in scale if compared with respect to planets. But this is also a celestial body which is similar to that of Earth, because we all know the hypothesis is everything is from the same thing. So when one celestial body we are getting, we are kind of inferring what about the, when I'm studying about the meteorite, its internal composition, I'm kind of taking ideas. Okay, if this is also, these are the things happening to that celestial body, this is also a celestial body, the planet Earth. So maybe this is also the same pattern would follow. So that indirectly we are kind of getting information. And number 4 is seismic activity. What is seismic? Seismic means earthquake related. Seismic activity means when earthquake happens, waves are released. And these waves, there are various kind of waves which we will learn in class 11 in depth. But for the time being, just know there are waves which pass only through solid, which pass only through liquid. There are various kinds of waves. So when these waves pass, it is noticed where it is not seen, where a distance where it is not seen, that is identified. Okay, because this kind of wave is not seen in liquids, and this is the area where it is not seen. So it's inferred, okay, this region maybe it's liquid or molten in shape, molten in composition or structure or texture, whatever. So these are the things how we know about the interior of the Earth, because it's not possible through the direct sources. We have to take the help of indirect sources to get a comprehensive idea about the interior of the Earth. So now that we know how we know about the interior of the Earth, let's move on. The actual chapter will start now. The structure of the Earth's interior now is made up of, you can see, several concentric layers. What does this mean? Basically, concentric circles or concentric layer means which have the same center. You can see there are 3 circles are there. Each circle, it is increasing in size, but they have the same center. So similarly, the way it's given here, following the same pattern, the Earth's layer is also divided in such a way, Earth's structure, the entire interior of the Earth is divided in such a way that it is formed of concentric circles, because we all know, or concentric layers, we all know the shape of the Earth is that of an oblate, spheroid or geoid, or an ellipsoid, or a sphere or spherical insect, right? So obviously it will have, and it has been observed that the layers that are observed, they are concentric circles. And you might have a question now, that how are these layers identified even? So these are the things that you're going to learn. 2 types of things are there. First is mechanically their Earth is divided into various kinds of layers. So what are those layers? Let's see. Lithosphere, you studied, right? Atmosphere, mesospheric mantle, outer core, inner core. So these are basically the layers or divisions. What? On the basis of the mechanical divisions. Mechanical means something related to state, temperature, these things. Something, for very crudely, it is dependent on the state of that thing. Whenever we are observing any difference in state, we, on the basis of the difference in the physicality of the regions, we have divided it, right? And chemically also, we divide the Earth's surface, Earth's structure into the crust, the mantle, and the core. And it is further subdivided, but crudely, these are the things. So mechanically also we have divided, and chemically also. Chemically means here you will crudely to say it's the chemical composition on the basis of which it is being divided, right? So mechanically and chemically it's been divided, and all these layers are in form of concentric circles. Clear? And concentric circles, number 1, and the divisions are on the basis of this. Now, first we will be dealing with the mechanical divisions of the Earth, and then we will be moving further with what? The chemical divisions. So here you can see the mechanical divisions. This is basically a vertical section of the Earth has been taken. First you can see the lithosphere. The lithosphere is basically something which ranges from about 5 to 200 kilometers. Okay. Below that is the asthenosphere. The lithosphere is solid in shape or texture. The asthenosphere is molten, in molten state. The mesospheric mantle, the lower part, it is solid in state. The outer core is liquid in state and the inner core is again solid in state. So on the basis of the difference in state that is being observed, they are being divided. Now to know more about them, let's see the various kind of qualities that they have or characteristics. Now the lithosphere, as I already said, its thickness ranges from 5 to 200 kilometers. And thickness and depth has a difference. Always remember, thickness means its thickness and depth means its thickness plus if something was below it, above it, so plus that, right? So that I think you already know. The lithosphere is the first 5 to 200 kilometers of thing that mainly covers the surface of the earth, right? So its state is solid, as I already said. Its temperature is about, the highest temperature that it reaches is about 200 to 400 degrees Celsius, right? Now to remember, right, to remember one thing, you must understand one thing, that per 1 degree Celsius, there every 32 meter depth, 1 degree Celsius increases. With every 32 meter depth, as we go down, 1 degree Celsius increases. So here you can see the temperature increase has been there, noticed, and even the pressure increase has been noticed. What is pressure? Why pressure increases? We all know as weight is above it, I'm placing a weight, above it, another weight. So below enough force is working, huge amount of force is working. So gradually the lower portion will have what? The inner core will have the highest pressure, right? So here we have understood why pressure increases, right? So now pressure, if you notice through all these layers, lithosphere is above asthenosphere, asthenosphere is above mesospheric mantle, mesospheric mantle is above outer core is above inner core. So the inner core is the innermost part. So if you notice, you will see the pressure is the highest there. Why? Because the entire weight of above all of the layers of above it, the entire weight of all the layers above it is working on it, right? So this is obviously going to make it, we know pressure is what? Force by area. So when the force is increasing, it is very obvious that the pressure will increase. So with all these layers, pressure is increasing. Temperature also, as I already said, I will not be reading out numbers because it would be redundant, right? So here I would be saying with per 32 meters, after going downwards, what we notice? We notice 1 degrees increase. So here, as you can see, the lithosphere, which is reaching a highest temperature of about 200 to 400 degrees Celsius. The asthenosphere, which I said, here you can see LVZ zone, low velocity zone. Why? It is viscous. And obviously, you know, some viscous means dense liquid. Just think of it as a dense liquid, something which is molten state, right? So obviously, where density is more, what we know, where density is more, it is very difficult to go through. So here the waves go through very slowly. So that's why the earthquake waves, obviously, which are used to know about the interior of the earth. So here they go very slowly. So this is the reason why it is known as LVZ zone. This is the asthenosphere. It is at it's at a depth of around 400 kilometers. Thickness is 400 kilometers and it is ending at about 660 kilometers, right? It is at if I have to measure the depth up to, it is 660 kilometers. State obviously molten and temperature, it's very obvious. Now asthenosphere and the lithosphere. The asthenosphere is liquid, it's dense, and the lithosphere is kind of comparatively, it has lower density. So the lithosphere floats over the asthenosphere, and lithosphere are basically the structure, the surface of the earth, and below it is this molten layer. When the molten layer, obviously we know it moves. As it moves, these plates, the structure also moves with it. Above it, it moves with it, right? As it is moving with it, so this is causing, sometimes it is coming closer, which is forming the huge continent, supercontinent of Pangaea, and sometimes it is going apart, and now we are seeing the Atlantic Ocean is also increasing. Because of this, because the asthenosphere is moving, remember, due to the asthenosphere is molten in state, so it's very viscous, so it can move. As it is moving, the direction is determined by a different force, which you will learn in class 11 if you take geography. But for the time being, just remember, because it is in molten state, it is very obvious that it will move. And as it is moving, it is taking with it the above structure, the surface of the Earth, the lithosphere, because of which we are sometimes seeing widening, and sometimes like the Atlantic Ocean is widening and the Pacific Ocean is shrinking, right? The mesospheric mantle is solid. It is about 200,000 kilometers and it is at a depth of about 2900 kilometers. Solid, and obviously if the pressure is increasing, it's very obvious. The outer core, 2200 kilometers. It is at a depth of about 5100 kilometers. It is liquid in state. Why all these things you will be learning in the chemical composition. Now just remember the temperature, the pressure and the depth, right? Now here you can see per 1 degree Celsius, every increase per 1 degree Celsius for every 32 meter depth. So as I have already explained. So as it is increasing, as you have seen there also, the inner part of the Earth, the inner core has approximately 5000 degrees Celsius temperature. So obviously at the surface it's ranging about, starting with what, maybe 50, 10, and as slowly increasing, and at the inner core it is reaching approximately. Here also I am giving you a disclaimer, this is not absolute. Some books you may see a bit more, some books you may see a bit less, but it is an idea that this is this extreme. So this is that. And I explained to you obviously that the asthenosphere, the oceanic crust, the continental crust, these are basically the lithosphere. Just for the time being, remember this is lithosphere, right? These are the plates, and the asthenosphere is the molten area. Here, this yellow we are circling, this is the molten layer, and because it is moving, the lithosphere is also moving, right? So this is causing what? This is causing the movement of the plates, the lithospheric plates. You will come to know about the term called tectonic plates, right? But for the time being, just remember these are lithospheric plates, or you can say also tectonic plates, right? So this is the reason why we are seeing increasing or decreasing in the ocean length, whatever. And sometimes we have seen the Pangea, it has been observed, but now it's the number of continents that it exists. Now, the chemical divisions of the Earth, right? Chemically, Earth can be divided into 3 parts: the crust, the mantle, and the core. And again, these are subdivided, right? The crust is divided into 2 parts, the mantle is divided into 2 parts, and the core is divided into 2 parts. And here, what is the basis of classification? Whenever we are classifying, there is a basis, which kind of states, or which is the reason behind the classification. We are boxing or we are grouping. The grouping needs to be having some reason behind it, right? So it is a chemical composition. So let's start with the crust. The crust is basically, physically what we call the lithosphere. It is the outer surface of the Earth. Chemically we call it the crust, the outer surface of the Earth, the Earth structure. Now this is the area where we see sea, we see deserts, we see land. Basically this is the covering of the Earth's surface, right? Now this is divided into 2 parts. The crust is divided into 2 parts chemically. The first part, the second part. The first part is known as Cl. The second part is known as Sima. So what is Cl? Cl is an abbreviation. It is basically silica and aluminium layer, because predominance of silica and aluminium is seen in this zone. And below it, the oceanic part, or Sima, it's the oceanic part. And Cl is basically majorly found in continents, and Sima is found beneath oceans, as majorly oceans, and beneath continents also it's same. So basically we will be learning about it. Sima is silica and magnesium. That's the chemical composition difference, right? So detailed difference we will be studying. Let's see. Here you can see the Cl. It is the uppermost, it's the outer surface of the Earth. The entire Earth, the entire surface of the Earth is known as crust chemically, but its outermost surface, or the uppermost surface, is known as Cl. And the Sima is the surface below Cl layer. Its thickness is nearly 20 kilometers. It's about 25 to 30 kilometers, right? Here it is a granite layer. Cl Sial is mainly seen to have deposits of granitic rocks, and Sima is seen to have deposits of basaltic rocks. Here, as I already mentioned, the chemical composition is silica and aluminium. Here, in case of Sima, it's silicon and magnesium. Sial is less dense. It's about 2.7 gram per centimeter cube, and it is more dense. Sima, it is 3.0 gram per centimeter cube. Now, here comes a concept. Always less dense particles float over more dense particles. So there is a proverb that in the geographical community we say, the Sial floats over Sima. You're getting the idea. The Sial floats over Sima. Why? Because the Sial is less dense, so it can float over the more dense Sima, right? We know, we have seen icebergs also and all the things where the water surrounding and the whatever is floating is of less density, and whatever in which it is floating is of more density. The oceanic, and this is a continuous layer, not a continuous layer. Sial is not a continuous layer. Why? Because it is majorly found or only found in continents, beneath continents, or the continental layer. But it is not seen in oceans. For oceanic crust, it doesn't comprise. But the Sima, it's a continuous layer. It is found both beneath the oceans as well as beneath the continents, right? So here you can understand the oceanic crust is typically about 5 to 10 kilometers thick, and the continental crust can be up to 40 kilometers thick. Now, this is the lithosphere if I have to divide. This is the Sima and this is the Sial. You can see the continent part only, it's not a continuous layer. Where continents are there, the Sial will be there. But Sima, it's a continuous layer. Why it's a continuous layer? It is seen both in below or beneath the continents and also beneath the ocean floor. Or the ocean floor, in the oceans also it's seen. And this is the lithosphere. Why? Because this lithosphere, you remember, it's a mechanical composition. Mechanically, the part which is comprising the lithosphere is basically the crust. And upper portions of the next what we'll be studying, the mantle, right? Now, here you can see the Sial. Here, what you will notice, previously we have noticed what? Previously, while doing mechanical divisions, we have noticed difference in state. Here, we will be noting difference in densities, composition and stuff. So, wherever there will be a discontinuity, here you can see the name Conrad discontinuity. Various types of discontinuities you are going to learn here, right? So, these discontinuities are the areas which shows the sharp contrast between the above layer and the below layer, beneath layer. So here, because we have known the Sial and the Sima layer has its own distinct chemical compositions, so it is between them passes a discontinuity which is known as the Conrad discontinuity. And as I have already mentioned, the lighter Sial, which is of less density, is floating on the denser Sima, right? So Sial, Sima we are done with. That is the part of the crust. Now we are left with what? You can see these are the inner layers. Now we will be studying about the mantle. We are done with the crust. Now mantle. I also said previously that crust is divided into two parts. Mantle is also divided into two subdivisions. The upper mantle and the lower mantle. It's quite obvious from the name, but let's see. Here the above portion, 70 to 200 kilometers, that means the green shades regions are the crust. The red region is the what I will be saying. The yellow region you have seen. Now you can see another yellow region, the upper mantle, the lower mantle. Here also basically what is the reason? Maybe the difference is because there is a difference in composition that is noticed. Now what is the red area? The red area is obviously not the crust because it is previously shown the green area is the crust. Now the red area is part of the upper mantle, but it is so important that it is distinctly shown. This is what you have already studied as asthenosphere in the physical or mechanical divisions. So here I am not mentioning about it, but remember it is also part of the upper mantle. Now upper mantle, lower mantle. The upper mantle is till a depth lower mantle starts about 700 kilometers and ends at 2900 kilometers, and the upper mantle starts at about 600 kilometers and moves up to 700 kilometers. Now, the crust is a layer, the mantle is a layer, the core is a layer. The crust, two layers are divided, cone-rod discontinuity. But the crust and the mantle is also divided, right? It has its own distinctions in terms of chemical composition. So the crust and the core, crust and the mantle is divided by a discontinuity which is known as the Moho discontinuity or the Mohorovičić discontinuity, which is after the famous person, Mr. Mohorovičić, who discovered the discontinuity, right? Now, the upper mantle and the lower mantle. Here you can see the upper mantle, beside the upper mantle it's written Crofosima, and beside the lower mantle it's written Nifesima. So these are basically short abbreviations of the chemical compositions. But these we are going to learn. These has its own meanings, right? So we will be seeing it. For the timing, just remember these are abbreviations for the chemical compositions of this layer. So the upper mantle and the lower mantle is divided by, again, like the upper core and the inner core, upper crust and the lower crust, the Cial and the Sima, it is also divided, and the discontinuity is known as repetitive discontinuity. The upper mantle has a density of about 3.3 gram per centimeter cube, whereas the lower mantle has a density of about 3.7 gram per centimeter cube. And densities, obviously, you can see, is dependent on what? The composition of things. And here you can see there is a slight difference in the composition. Majorly it's same. You will learn about the olivine, presence of olivine and the pyroxene rocks. But a slight difference is there. But there is a difference in density, which is marked by a discontinuity known as repetitive discontinuity. Now the upper mantle and the lower mantle, right? The upper mantle, I said what? The upper mantle is part of the asthenosphere, the physical portion, right? So it is molten, we have already learned it. That's why the lithosphere peak plates move over it. And the lower mantle is solid in state. Here, various things that we are noticing, why solid, why liquid. At the end of the chapter, I will be giving you a complete explanation. Why it's solid, why it's liquid. Basically, the upper crust is solid, it's there, right? But why is the asthenosphere liquid? Because of its composition per se. But why is the lower mantle again solid? Because of the immense pressure that is working. Everything has to have a melting point. If you reach a certain melting point, only then something melts. It is at such a distance, the lower mantle is composed of such things that its melting point is not reached, so it becomes solid. But the upper mantle, the temperature and its composition is such that the melting point is reached. It has comparatively lower melting point and the pressure is low. Though the temperature is increasing, if you see with depth the temperature increases, but the pressure is such, the pressure is so huge here, that's the reason why the lower mantle is solid but the upper mantle is molten. Now mantle, again we know that upper mantle, lower mantle. Now upper mantle, as I have already said, we have to discuss, right? So it's the asthenosphere, I have already said, or the lower velocity zone. Why the lower velocity zone? Because here the earthquake waves become less in speed. It has less speed comparatively. Why? Because we know the more is the traffic, it's difficult. More density means more traffic per se. Now the upper mantle, the temperature ranges between 850 degrees Celsius to 2208 degrees Celsius. These are facts. Now the upper mantle is composed of, what are the compositions, right? It's the chemical composition part. So what are the compositions? The chromium, the ferrous oxide is iron, silicon is silica, and magnesium. And all these things is giving us the abbreviation Crofesima. Crofesima. You can understand why is there this layer beside that it was Crofesima, because these are the compositions or the things that this layer is composed of. So now we are done with the upper mantle. Now it's part of the lower mantle. So the lower mantle is solid in state and it's composed of nickel, ferrous oxide, silicon, and magnesium. So it's called nephesema. So that's the reason why it's called nephesema. So now we are done with upper mantle, lower mantle also. Now the two divisions, crust, mantle, we are done with. Now the upper mantle and lower mantle discontinuities also we have done with. Now let's see. You can see the mantle, the upper mantle, lower mantle. Now again, as I have studied, or as I have said already, the crust and the mantle was divided by the more basic discontinuity. Again, because the divisions are there, the mantle and the core will also be divided on the basis of its chemical composition or density or whatever, in terms of its chemicality. So it is, the discontinuity is given or founded by Gutenberg. So again, the name of the discontinuity is Gutenberg's discontinuity, Gutenberg discontinuity, and it is about at a range of about 2840 kilometers, right? Now we are left with the last layer in terms of chemical composition, the core of the earth or the barysphere. Why the barysphere? You will be learning. First, let's understand the core of the earth. This is the innermost portion, is the core. And this layer was founded by Richard Dickson Oldham. Richard Dickson Oldham, right? This is the scientist who have founded this. Now the core of the earth, it is at a density, immense density. Density of the core is about 13 grams per centimeter cube. In the center, it ranges between 13 to 15 also at times. So because it is of such huge density, which is why it's given the name of barysphere, because barysphere means heavy. Because this layer is composed of such dense materials, so this is the reason why the name of this layer chemically is also known as barysphere. Now the core of the earth has a radius of about 3500 kilometers, and it has an average temperature of about 5000 degrees Celsius, which you have already studied in your what? The physical divisions or the mechanical divisions also, right? Now, the core of the earth is composed of mainly two kind of metals, nickel and iron. So its name, in chemically an abbreviated layer name is given, it is known as knife, N-I-F-E, so knife. Clear? So this is the reason why the core of the earth is known as knife. Now the outer core and the inner core both have the same composition, but still, as we have already learned, we will see there is a difference in their state, physical state. The outer core and the inner core. The outer core is mainly what we have studied previously. The outer core is liquid in state. And because it is liquid in state and it has iron in it, this liquid state, we know liquid things move. Because these things move and it is at such a depth, these things move and it creates something called dynamo effect, which results in the magnetic field of the earth. This is the reason for the earth to have its magnetic field, right? So the outer core is liquid, but the inner core is solid. Now you can question, why is the outer core liquid and the inner core is solid when it has the same composition? Because the outer core has compared, what is the temperature and the pressure thing? The inner core has immense pressure because of the huge weight that is working on it. But in case of outer core, what happens? The outer core is it hasn't have the pressure. Whatever pressure it has, it is not enough to cross its. It is enough to cross its melting point. But in case of inner core, it is not enough to cross its melting point. So it is solid in state, and the outer core is liquid in state. Now here you can see we have already learned the mantle, the crust, and stuff. Here we will learn about the core. That's the outer core, that's the inner core. The outer core is ranging from about 2900 kilometers to 5100 kilometers, whereas the inner core runs from about 5100 kilometers to 6350 kilometers. Right? Now again, the outer core and the inner core is divided by a discontinuity. Why? Again, there is a difference that is noticed in terms of density and stuff. So here, what we call it? Again, the discontinuity is called Lehmann discontinuity. Again, because of the individual, Miss Inge Lehmann, who identified or discovered it per se. So this is liquid, this is solid, which you have already studied. Where you have studied all this. These are the things that you've already studied in the mechanical classifications. Now the seismic discontinuities, all the things are given where we have mentioned about the Conrad, the Moravisic, the Repetiti, the Gutenberg, and the Lehman. These are the things that are already explained, so I will not be going into detail. You can take a screenshot and learn about these things. Now here a chart has been provided. I have explained everything in detail. A chart is being given here. Why? For your betterment or for your benefit. This chart, if you study, this will give you the complete information in a tabular form. Here, Cr, silicon and aluminum, Sima, silicon, magnesium, upper mantle, chromium, iron, silicon, magnesium, lower mantle, nickel, iron, silicon, magnesium, outer core, nickel and iron, inner core, nickel and iron. So the abbreviations are also Cr, Sima, Crofesima, Nifesima, knife. So these are there. The depths also you have learned. The states, that means solid or liquid, though it's not very important in terms of, because these are the, you've already studied in the physical classifications, but still I have given. And the inner core, you can see the highest temperature. Why? We have known by the gradient, right? The gradient works in such a way that per 32 meters of depth as we go, 1 degree Celsius increases. And why pressure? Again, the same concept, because the layers one above the other. As many layers are increasing, the one which is below will be facing the force of everyone, right? So the one which is at the innermost will be facing the most amount of pressure. Here we can see it's about 330 to 360 gigapascal. And here you have, I think you have understood, there are the units that are also given. Now we are already done with the chapter. If you have any doubt, I hope you will not have any doubt, because I have tried to give you a comprehensive idea of the entire chapter. But if you have any doubt, please let me know in the comment sections below.